In this video, we will look at few more real-life applications on a normal distribution. I'm going to be using StatCrunch and TI-84 graphing calculator. If you prefer using formula, the conversion formula, and the table A2 and need some refresher in it, then you can watch my previous video on how to use the conversion formula and table A2. Let's read the first problem. Scores on a test are normally distributed with the mean of 66.9 and a standard deviation of 11.4. Find P81, which separates the bottom 81% from the top 19%. So we're looking for the 81st percentile. Let's draw a graph. It's a normally distributed set of data with the mean of 66.9 and a standard deviation of 11.4. We need to find percentile 81. 81% to the left of that value would be approximately this much, 0.81. So we're looking for this test score. It's located to the right of the mean. It's greater than the mean. Let's use StatCrunch first. Go to Stat, Calculators, Normal, adjust the mean to 66.9, standard deviation 11.4. The direction of distribution is to the left. Leave this space empty because that's the score that we're looking for. The area to the left is 0.81. The score that separates 81% from 19% is 76.9. Let's read the next problem. Assume that women have heights that are normally distributed with the mean of 63.6 inches and a standard deviation of 2.5 inches. Find the value of the quartile 3. Remember, quartile 3 represents 75th percentile, or 75% of the area located to the left of that value. So we draw a graph with the normal distribution, mean of 63.6 inches, standard deviation 2.5 inches. We are going to use StatCrunch, normal distribution calculator. So select Stat, Calculators, Normal, adjust the mean to 63.6, standard deviation is 2.5, 75% or 0.75 is to the left. So make sure to check the direction of the probability, less or equal to. Leave this box empty. Area 0.75. Compute. The value of quartile 3 or 75th percentile is 65.3 inches. Let's read problem number 3. The weights of certain machine components are normally distributed with the mean of 8.13 grams and a standard deviation of 0.09 grams. Find the two weights that separate the top 3% and the bottom 3%. These weights could serve as limits used to identify which components should be rejected. Round to the nearest hundredths of a gram. I'm going to draw a graph to help us better visualize what we're looking for. The low 3% located on the left side and the top 3% located on the right side. Let's first find the value that separates the bottom 3%. In the StatCrunch, we change the mean to 8.13, standard deviation 0.09. The direction for the probability is to the left of the z-score. Leave this box blank. The area to the left is 0.03, 7.96 grams. Now let's find the value that separates the top 3%. In the StatCrunch, we will change the direction of the probability to the right of this z-score. So leave this box empty. Change the area to 0.03. Compute. 8.999 rounded to the second decimal is 8.30 grams. We will now use TI-84 graphing calculator to solve these three problems. Or I should say to double check the answers we got previously using StatCrunch. In the first problem, we need to find 81st percentile, given that scores on a test are normally distributed with the mean of 66.9 and standard deviation of 11.4. In the graphing calculator, we are going to use InvNorm. Click second, vars, down to InvNorm, or you can click 3, enter the area, 0.81, mean 66.9, standard deviation 11.4. Tail is going to be on the left of the value. Go down to paste, enter. And if you have TI-83 graphing calculator, then that's what you will input: area, mean, standard deviation, and the direction of the tail. Click enter again. The test score that separates the low 81% from the high 19% is 76.9, so the first answer is the same. In the second problem, we need to find the value of quartile 3, which is 75th percentile, given normally distributed population of the height of women with the mean of 63.6 and a standard deviation of 2.5 inches. Go to second, vars, InvNorm, enter the area, 0.75, adjust the mean, 63.6, standard deviation, 2.5. Tail is also on the left because percentile is the mark that separates the low 75% from the high 25%. Go down to paste, enter again. Quartile 3 is 65.3, so this answer also checks. Now let's look at number 3. In the third problem, we're given the weights of certain machine components that are normally distributed, the mean of 8.13 grams and standard deviation 0.09 grams. We need to find the two weights that separate the top 3% and the bottom 3%. The bottom 3% means that we're looking for the weight that separates the 3% on the left, or 0.03. So let's use the graphing calculator. Go to second, vars, InvNorm, enter, adjust the area, 2.03, mean, 8.13, standard deviation, 0.09, tail is on the left, paste, enter again. The weight that separates the bottom 3% is 7.96 grams, which also checks. And finally, the weight that separates the top 3%. Again, go to second, vars, InvNorm, enter, area is 0.03, mean is the same, 8.13, standard deviation 0.09, tail is on the right. Go down to paste, enter again. The weight that separates the top 3% is 8.3, rounded to 2 decimals. So this answer also checks. So which method is better? Well, you could see from the examples we solved that regardless the method we use, whether it is Table A2, StatCrunch, or graphing calculator, or other technology, we get answers that are considerably close. Of course, for more precise results, the use of technology is preferred. Hope you found this video helpful.